I had cut you off before. Was there something? Do you still remember what you were going to say before, or did you lose it?
I mean, I guess we can. So what I was sort of starting to explain is how this works. Like, if I, for example, draw a box. This is going to be a bit more technical, but
be as technical as you want to.
If I draw a box, that creates a node, and that node is just a node that returns a rectangle. We then feed that node into another node, which gives the rectangle a stroke, so like an outline. We then feed it into another node, which gives the rectangle a color.
A fill color.
Yeah, a fill color. And that's how we can, like, you did your operation, you drew a rectangle, but now we translate it into this set of like operations. And if you want to change the color, you still have the same geometry. You can reuse the geometry from the rectangle node and just go to the fill node and change the fill color. And that's sort of the mental model we work with in Graphite.
Yeah, and of course the important part is that the tools did that for you. You could go to the node graph, add your own rectangle node, then add your own stroke node and your own fill node, and set up the color you want for the fill and the stroke, set up the width and height for the rectangle, but the tools can just do that for you. And it's much, much faster to just draw it like you would in any other graphics editing program. You just draw a rectangle. It's truly that simple. And the system adds that node, that set of nodes for you, and it becomes a layer. The important part is we still have the layer system as well. So the nodes feed into a layer. Essentially, you could think of layers existing in other graphics editing software. They just internally represent in whatever internal data structures that the software developers created for their use case of, for example, vector graphics or raster graphics. In those cases, they've built some internal data structure, but you don't have any control of what that is. And it's just storing whatever you drew. But in our case, the layers are more like outputs for the data that the node graph generates that either you don't see or you see, depending upon whether you open or don't open the node graph. So they're more of outputs for that data that gets generated along the way. And you have, therefore, more control over that. But at the same time, it could be exactly equivalent to other software if you choose to never open the node graph.
And I think one of the sort of natural transitions we could do here is that we did already talk a bit about the sort of adaptive resolution idea. So we don't pick a resolution up front, but rather we record like basically all the user inputs and we can render it at a different resolution. What we can also do is that and I did also mention this, we only render what's currently visible. So previously I described that basically the entire thing, like the entire document becomes a function with inputs and outputs. So it's a program that takes some input and returns an output. One of those inputs is the area you're currently looking at and the resolution. So the current viewport position is an input to the program. And in that sense, Graphite becomes basically more like a game engine because on each frame we have to render the artwork with the current camera position. You could sort of think about realizing this as a sort of 3D map. If you place your image in 3D space, we have a rectangle in 3D space, and you can then move your camera. So in a sense, we're much more similar to how a game engine would work. And that does naturally lead us to one of the biggest concerns we always have to worry about, which is how do we make all of this fast? And
right. Because it's nice to be able to do this, but if you need a 5090 for it, it's not exactly...
Yeah.
It's cool. Like, it's technically cool, but it's not viable.
And we want to work on low-end like Chromebooks and things in classrooms. Because in fact, the classroom market, even today, actually, we've been looking through our analytics and seeing about, I think, around 20% of our visitors are coming from classrooms during the weekdays. So it really is actually an important market, and that's only going to grow over time as the skills that are taught in classrooms need to be more and more technical and more focused on creativity as opposed to just the traditional subjects. So I expect that to grow, and we want to make sure that we're as accessible as possible to all users, whether that's on Chromebooks or whether that's on a 5090 with a nice beefy gaming computer. We want to support everything in that entire hardware range between those. Yeah. And of course, you mentioned like basically a server GPU there as well.
Yeah.
We also want it to be able to, if you are an actual film studio, which normally has to produce graphics like 3D graphics that usually go off to a render farm. We even want to support a case where because we're basically building this generalized graphics engine in the same way you think of it as a game engine, we want to be able to generate something that is so computationally expensive if you're crazy with it and you're generating, like you're importing like a terabyte of data that's used to do data visualization or something. We want to support a case where we literally are the software running in a render farm to render frames offline in some case where it takes 15 minutes to render every frame like you would for a 3D movie or something.
Right.
So we really want to support the entire gamut between actual render farm hardware down to Chromebooks.
And actually, talking about where you use Graphite, currently we have a web app. And we are also working on a desktop release that's going to come soon, and we'll maybe talk about that a bit later.
Yeah.
But first, the desktop, the web app. It does use JavaScript. We do use Svelte for the front end, but all of the logic is written in WebAssembly. It's written in Rust and compiled to WebAssembly. So our main editor has always, from the ground up, built with having a native desktop app in mind, and we use Rust for basically everything that matters, and only use the web for the UI because the web is just good at UI. And that's sort of the tech stack we're building towards. And yes, I needed to mention that it's written in Rust because that we are obliged by the Rust Foundation to mention this.
We are not actually obliged by the Rust Foundation to mention this.
It's also important that, because I know people are going to see it has a web app and immediately like write it off. It also is important to mention that is what was done first. That is not the final goal of the project.
Yeah.
And it's not...
I talked about strategy earlier, and it's really about the strategy of finding what battles to fight at what time in the roadmap, while eventually knowing that you will win every single battle. And we even have a roadmap towards eventually getting rid of any web technology at all further down the road by having our own render engine be so sophisticated that it can render our own UI in itself, where you can update the appearance of a button in your own editor while the buttons all throughout the rest of your editor update live while you're editing that one button. So
yes, that's the other thing. The intention is also not to be, I know people are going to immediately think because it is on the web right now, it's going to be an Electron application.
Yeah, no Electron.
No Electron.
To be clear, it is built as a native app using a native language that gets compiled into a format that simply is capable of being hosted within a browser. But it is a native app running in a browser, which technically, based on how you want to define things, you could call it a web app. But I think of a web app as more of something that's written in JavaScript. And aside from a tiny bit of UI code, it's like 5% of our code base that just accounts for like, these are the buttons you can press. These are the drop-down menus you can select from. Those are just really lightweight things. We've intentionally built everything to be as lightweight as possible. We're not really using any libraries aside from like our UI framework of Svelte, because we know that libraries typically add like 10 times as many elements to the HTML DOM compared to what you need, and we don't want that. So I want to build my UI that I designed as part of the UI mockup in as few HTML elements as possible, using as few lines of JavaScript as possible or TypeScript, just to be that like 5% of our code base that involves just the things you see, the things you click on, the things you interact with surrounding your viewport, knowing that you spend most of your time in the viewport, drawing and painting, not actually touching buttons and things, because those ultimately are not latency sensitive. They are like the UI, if it's written well, if it's not written with thousands and thousands and thousands and thousands, maybe hundreds of thousands of lines of JavaScript, like you might expect Slack or Google Docs or Teams or whatever desktop applications that tend to be, or Discord, they tend to be rather bloated and have a high latency, and that's just because they're running through a tremendous amount of JavaScript. Whereas in our case, we are running through maybe like at most 100 lines of JavaScript when you click on a button or something, and that's just instant, like nanoseconds, not milliseconds. And then it's running native code after that point. In this case, in WebAssembly. But as soon as we have that desktop app is running directly Rust code, so compiled code. And the reason we say Rust is because it's important to know it's not JavaScript. It's Rust, which you can basically think of as equivalent to C++. It's just we're starting a brand new project, and Rust is the more modern language to use instead of a 25-year-old C++. So that's why we chose that. It's mostly for maintenance reasons, that we can make really large-scale applications and have the compiler make sure that it knows that we are not making mistakes that C++ would have a harder time catching.
I was about to ask you why the choice of Rust, but you pretty much already answered it there.
It really is just about maintaining a very large-scale code base. It's easiest to do that in a modern day in Rust. We care about high-quality code because this is going to live for decades. And as a result, it's going to do a better job than C++ will at making our lives easier.
And another usage is, or another reason is that we need basically the full range. We need both low-level implementation, and we need to be able to optimize things because it's going to be very performance sensitive. And we also want to use one language and have the full range to application scale and have all the abstractions we would want from a language.
It's kind of
the editor UI.
It's kind of the first programming language that allows you to have low-level speed, like basically C++ style low-level systems programming with high-level conveniences, which is not something that C or C++ can deliver on. They don't really provide those high-level conveniences, where we get to mostly feel like we're writing in something like Python or JavaScript or Java, where it's like a high-level, or C#, where it's high-level conveniences, and we get to therefore maintain a really large-scale code base and not have the burden of worrying about when things just totally collapse because the Jenga tower you've been building for the past 15 years has just collapsed from beneath you, as it would in C or C++, where the moment you got to go refactor some big system, it just becomes this nightmare of finding bugs for months and months and months, and users hitting crashes because you changed the foundation out from underneath you.
And that's also like if we get new contributors, and some people just add one feature that they like that was annoying them, and they make a PR for it. It's easier for us to have confidence that their implementation won't break other things. If we know that it's compiles, we know it doesn't introduce any undefined behavior, that's always like a good start. And then we just need to check if the logic actually works.
Also, the one last thing that can't be under accounted for is that Rust as a language, because it's newer and it's a little more like fancy and stuff, it ultimately attracts really smart people. So Dennis is like actually a genius, and we would not have found, starting the project, we would not have encountered Dennis if it were not chosen. If we were just using C++ or something that has, heritage as a multi-decade language that thousands or millions of people know, it doesn't have the community built around sort of a niche of really, really smart people who have self-selected themselves into a group of the people that we can ultimately recruit as open source contributors.